Hey, hi, champs of Examsnet. This side, Uttam Tiwari, your educator of physics and chemistry. I hope this series of detailed explanation of MSET paper is helping you a lot. In this series, we would discuss primarily the major chunks of the questions. I would be telling you short tricks behind every question because if you talk about this generally MSET paper, you can easily solve these questions are not that much trickier. You can easily solve by some of the short tricks. Second, I will be telling you chances of re-repeating of every question back to the exam because if you follow the certain trend, you can easily predict that which question can be coming in the next years, right? Because you can see this question number 123 even belongs to 2018 paper of MSET, the same question of diagonal relationship. So if this question is repeated in some other form, that would not be a surprise if I tell you this. So if you have any doubt related to any portion in this, you can just comment in the comment box and the telegram channel link is given in the description box, and I can bet if you follow this series of pyq you can still secure a very good marks in your upcoming exams. So without further ado, let's start this session. So this question we are talking is 123, and the question states that lithium shows diagonal relationship with element x and aluminium with y. So x and y respectively are, this question belongs to S block chapter, and even you can find this in NCRT page number 2, right? Because this is from the in text, and this is very basic question. When you talk about diagonal relationship, okay. So when you talk about diagonal relationship, this follows a certain trend. What does diagonal relationship means? Diagonal relationship simply means that the properties of the elements are similar. When you talk about density, you talk about even size, you talk about ionization therapy, anything. If you talk about in the terms of property of S block, they almost have similar properties, right? So they're just asking us. This is very easy question. I can even tell you one trick to remember. Just listen this. There's lithium, there is beryllium, there is boron, there is carbon, nitrogen. Write this. And then you can write sodium, magnesium, aluminium, silicon, and phosphorus. Okay. So I have, if you see, I have written the period 2 and the period 3, right? So what is the trick? Just match the column. Lithium, magnesium, beryllium, aluminium, boron, silicon, carbon, phosphorus. So when you match this, then I can tell you they almost have similar properties. And you can say lithium and magnesium have similar properties. Beryllium and aluminium have similar properties. Boron and silicon have similar properties. Carbon and phosphorus have similar properties. So the question has just asked us this one. You see, lithium shows diagonal relationship with element X. So which is element that? That is magnesium. So magnesium you can see is in this A and B option. Beryllium shows with aluminium. So this they has as aluminium. So that is the option A is the correct answer. Also, if the question is asked in the PYQ in the next upcoming exam as boron, silicon, carbon, phosphorus, that would not be a surprise question because I have already told you this. Okay, so let's get into the next question. So again, this question belongs to S block. So you see S block is having a good weightage in the paper. So they are asking us the correct order. Okay. So the correct order of metallic character of element beryllium, aluminium, sodium, and potassium. Now, when you talk about this question generally, this question is not much trickier. You just need to know 2, 3 ways to solve this. That is, I can tell you 2 ways. One, I can tell you that this would be repeated in again in the PYQ form. I can write even this. That is, when you talk about down the group, there's a trend followed in block chemistry that down the group, any block chemistry, if you talk about S block, you talk about P block. Okay. So down the group, metallic character increases, right? So they have just not, they have given in the mixed question, they have talked beryllium, aluminium, sodium, and potassium. So if this question asks in this way, you can solve in this way even. And there's other way to solve this question. That is, Electronegativity. Everybody knows like electronegativity along the period increases. When you talk about along the period, electronegativity is increases. Electronegativity, when you talk about down the group, it is it decreases, right? And when you talk about electronegativity down the group increases, decreases, along the period increases, then when we talk about electronegativity, then it is inversely proportional to metallic character. Okay. So any question is asked from neither this, like if you talk about S block only, you can solve either it is of group 1 element, group 2 element, alkali or earth alkalis. If that goes to boron family, carbon family, nitrogen, oxygen, fluorine, even helium family, any family if you talk about, right? Either on S block or P block, this relation is purely valid. So after checking this, electronegativity, electronegativity down the group decreases, along the period increases. So option A would fit in the mark, right? Because you see potassium, right? So potassium has high metallic character because it has a low electronegativity, then goes to sodium, then aluminum, and then beryllium, right? So let's go into the next question. So when you talk about this question, this is some kind of question is just not repeated in this way. This can be asked in many ways. The question has given us four statement. They have just in every part A, B, C, D. You can read. They have talked about covalent character. There's a what covalent character common in this all. You can see, right? So they can just not ask covalent, they can even ask polarization, they can even ask ionic character, even can ask acidity, more of which element, which compound, right? So they can even ask in this way. So to all the set, even this is repeated in J, this one question, of covalent, which is more covalent, is repeated in the J P by Q one. This is a very common question. This comes from the Fazan's rule. Fazan's rule of, again, you can talk if you purely say this question is of every block chemistry, even you can take it S block, this question comes to P block even. Okay, so Fazan's rule is if you purely talk, this is in chemical bonding, right? So Fazan's rule states what? Simple. It states that polarization is directly proportional to size of an ion divided by size of cation, and that is directly proportional to covalent character, CC. Okay, so they're just you can even, like, if question asked in the cation way, if question asked in the anion way, you can easily solve by this relation. This Fazan's rule, every question will be able to solve taking back that. Now, when you talk about size of cation, just let's look into the option. Option A has given us potassium fluoride, right? And this is potassium iodide, then SnCl4, SnCl2, LiF, and Kf, then ZnCl2, NaCl. Okay, so they have just this covalent character. Now you can see, you can just like once you have a look into C option, I can see like fluorine are same, right? If fluorine are same, the anion portion is same, so you cannot compare. You have to go to the size of cation now, right? So you see size of cation, which would have less size of cation, that would have more polarization. And if that would have more polarization, that would directly go to covalent character. So you can see lithium down the group. If you talk lithium, lithium would have less cationic size, right? So lithium, and then lithium, sodium, potassium, down the group size increases. Everybody knows that, right? So C option goes fit into the question. That's pretty easy. Okay, so let's go into the next question. The bond length C2N2B2 molecule X1, X2, X3 picometer respectively. The correct order of their bond length is, okay, not a surprise. This is again of the chemical bonding, and this is one of the very important questions. Every question I can I'm just right now saying is that they have a very high probabilities of re-repeating. Okay, so when you talk about bond length, one short trick I'm telling you, just you can solve every question. The short trick states bond length is inversely proportional to electronegativity, is inversely proportional to number of bonds. If the question states of bond length and electronegativity, you can solve. If it talks about bond length and number of bond, then also you can talk. Okay, so this is pretty easy. Now, how can we compare this? Boron boron bond. Can you make that? Boron boron single bond is there. Carbon carbon double bond is there. Nitrogen has a triple bond to it. So when you talk about boron, carbon, nitrogen, can you see there is one pi bond? In double bond, there is one sigma bond and one pi bond. And in triple bond, you have one pi bond, two sigma bond, two sigma bonds. Isn't it easy now? Talk carbon carbon. That is, if you talk, this is X2. Carbon carbon is X2, and nitrogen is basically carbon carbon is X1 way. Like carbon carbon is X1. This is X1. Boron boron is X3, and this is nitrogen is our X2, right? Now you can tell, I told you number of bonds. Okay, so bond length is inversely proportional to number of bonds. So which has high number of bonds? You can see X2 has high number of bonds, so bond length would decrease. X1 is two bonds, so bond length again decrease, and this is single bond, so you can easily predict the order X3 greater than X1 greater than X2. Even even this is the order of the single bond, double bond, and triple bond, because this question is somewhat similar. Okay, so again this is an important question I can mark. Okay. Now let's go to this question. Yeah. Now when you talk about this is something which is again from idle behaviors, right? So when you talk about the graphs, this gases, positive deviation, negative deviation graphs are very important graphs. So the question state that among the graphs A, B, C, D, among the gases A, B, C, D, E, and F, the gases that shows only positive deviation from ideal behavior at all pressure in the graphs are. You see, there is a graph drawn. For that, you must know what is positive deviation. You must know what is negative deviation. For now, you have to read I'll be uploading the lecture of this. You can read there. But for now, I can tell you in the brief what is positive deviation. How can you solve this question? Is positive deviation, negative deviation? They just ask us positive deviation. But when they ask you negative, and when they ask you idle gas, okay, they can ask in the upcoming exams. They've just asked you positive deviation, but they can ask even this. Okay, so how can I tell you this? This is a graph versus Z and P. Okay, x-axis you have P, and y-axis you have Z. Now, when you look into the question, there's a slight line. Can you see this? Right. So when you talk about if Z is greater than 1, that means above line that starts from origin, the straight lines. Z greater than 1 would have always positive deviation. And when you talk about Z less than 1, that would have negative deviation. For Z equals to 1, that would have idle gas. Can you see in the mark? Can you see this 1.0? It is already given 1.0 in straight line. That means this is an idle gas, right? So this question hasn't asked this, but it can ask something. Like Z equals to greater, there's asked is positive deviation. So we have to see Z greater than 1. Can you see there is only B and C lines that's starting from origin. A is coming from negative, right? And then going to positive. So this is eliminated, obviously. So A, B, and C is only the correct option. Can you see B, C, A option is correct option? Yeah, we have found this. Again, very easy question. Now let's go to the next question. Okay, now this question is just a theoretical question. The chances of getting these kind of questions are very less, but I suggest you one thing. This is law of definite proportion from some basic concept of chemistry. That is chapter 1 of 11th, right? So for these kind of question, I can what can I suggest you is that just keep rereading NCRTs of all the laws, right? Also, I'll be covering this in my lectures. So the question is stated that you have to tell the definite proportion. What the law of definite proportion states to you. Law of definite proportion generally talks you about, you know, they generally talk you about that carbon and oxygen are always in 3 is to 8 ratio. Okay, so every element is, it's present in the definite basically definite proportion, we can say, right? So carbon and oxygen is always produced in 3 to 8 ratio. So when you talk about their sources, they're not subjective to their sources. They're always irrespective of the sources. They will get same amount of percentage, right? So when you talk about which would fit the question, the ratio of oxygen H2 and H2O2 with respect to find mass of fixed mass of hydrogen atom is a whole number. This option is clearly wrong because that is the ratio of H2, and this is peroxide, right? H2O2 is peroxide. So this not comes as whole number. I've already told you. Percentage of oxygen in H2O is constant of irrespective of the source. Yeah, this seems correct. Yeah, this may be correct, right? Yeah. Well, let's look into C and D first. Equal volume of all gases at the same temperature and pressure should be contain equal number of molecules. No, exactly. That's not a correct statement. It's not necessary to contain equal number of molecules. Matter can neither be created nor be destroyed. This is not this law. Okay. This is not law of definite proportion. This is a conservation of mass law, right? So B is correct. Percentage of oxygen of H2O is constant with respect to of the source. I told you like this that is not subjective to the source, right? You'll always get this amount. You'll get always in this ratio. So this is a very correct option. Again, I prefer to read NCRT of some basic concept of chemistry. At least for this law, I'll suggest you to read starting 3 pages because that would cover all your laws. Okay. So next question. Okay, what are the oxidation states of three Br atoms in Br3O8 molecule? I can say even this question belongs to boron family, that is P block. And when you talk specific, this question even comes as a redox way, right? Redox reaction. So this is again a chapter of chemistry. Both are the chapters of chemistry. What student tends to do in this kind of question, the MSET has prepared this question a little tougher. Not, I would not say tougher because this is generally a trend of the question, but there are highly chances of re-repeating of this question. Because what student does, this is 3x minus, what they does, uh, oxygen goes to -2, so 8 to just 16, and that would give you 3x equals to 16 and x equals to 16 by 3. But this is wrong. You see there is no option matching with this, right? It has not asked us average because you have found this average. They have asked us individual, right? They have talked about BR, single 3 BRs they have talked about. So this goes failed. So if you are looking for this method, this would fail. Now let's see original method. Okay. So draw just 3 BRs. Oxygen makes double bond. So there are 8 oxygen. So oxygen, oxygen, oxygen. Always when there is a halogen always goes with a single bond linkage. So I'll suggest you to combine a single bond first, right? And then plant oxygen, oxygen. Then again plant oxygen, oxygen, and then one more oxygen. Right. Now Every oxygen is in -2 state right now here, right? This, I guess everybody knows. So now it's like pretty easy to solve. They've asked three BRs. Can you see one bond, two bond, three bond, four bond, five bond, six bond? So +6 is the oxidation state of this. One, two, three, four bonds. Again, this is +4. One, two, three, and four. Again, this is +4. So +6, +4, and +4 is a correct option. Can you see this in any option? So I hope this is a correct option. Wait, this goes 6, right? We have just made it a bit wrong. This minute. This is +6. We have left this. Yeah, this is +6. 1, 2, 3, 4, 5, 6. This is +6. So +6, +4, +6. B option is the correct option. Again, this is an easy question, but this can be repeated. So you can mark that as important. Now let's go into the next question. Identify the reaction slash process in which the entropy increases. Now, entropy question, again of a chemical bonding. You can say even ionic, this has some portion of ionic also, some portion of, the ideal gas stream. So you cannot define this question, this is a mixed question, right? So particularly, you can solve this question. It's a very easy question. I can tell you in one, direct trick. Any question comes of this entropy, always remember my point. That is, calculate delta Ng, the gaseous moles. If it comes positive, the entropy would surely increase. If it comes negative, the entropy would decrease. Okay. Everybody knows, if you don't know, solid and liquid moles are considered zero because we are talking about just gaseous. You see, G stands for gaseous. So let's go one by one. Let's calculate. See A option. A option, you talk gaseous mole. How you calculate delta Ng? Delta Ng, you have direct formula, number of moles of product minus number of moles of reactant. Number of moles of product. I'm marking this again, gaseous state minus number of moles of reactant. Moles. Moles of reactants. In the gaseous state, right? So again, go to the first option. What it is saying, can you see this is balance equation? So you have one mole right now in the product. So this is also in gaseous. You can see 1 minus. Can you calculate? There is 1 plus 1 mole, 2 moles. So 1 minus 2 would give you -1. Again, you can see this is solid. So this would have 0 because I've already told you this comes as 0. So 0 minus gaseous, you have 1 mole, 0 minus 1. This is again -1. This is 1. This is liquid, again 0. So 1 minus 0 would give you still 1. This is in solid. The product is in solid, so 0. Again, gaseous, you have 1 mole, 1 mole, 2 moles. C is in solid. So 0 minus 2, this would give you -2. Can you see? You just getting C option as positive because they have asked us increase. And when there is a positive, the entropy increases, right? So C option goes fit into this question. So C is the correct answer. Again, my trick is very important. You can solve any question of entropy. Okay, so let's goes to this question. Actually, this question has a little bit mistake, I guess. Let me find this out. I'll be uploading in the next lecture. Yeah, so we're on the next question. The formation of ammonia from its constituent element is an exothermic reaction. The effect of increased temperature on the reaction of equilibrium. As so, this is again from the equilibrium chapter of chemistry, the ionic equilibrium. Okay. So again, my tricks follows again here. I have so many tricks for you for this EAPCET paper, right? And even for the J. Okay, a neat aspirant can always, do this question with my tricks. So when you talk about exothermic, because they have asked us, if you see this question has asked us the formation of ammonia first. So let's go line by line. When you talk about a formation of ammonia, so how you make ammonia? This is a Haber's process, right? N2 plus H2 give you NS3. It's a name reaction, Haber's process, right? So preparation of ammonia. So can you balance this? If you balance this, that would give you basically two, because two nitrogen, and this would give you three. Again, this is a balance equation. Now, the effect of increased temperature on the reaction. So whenever there is an exothermic reaction, always, that always favors in low temperature. Favors low temperature. What I mean favors low temperature. That means when you increase temperature, and you would increase temperature, the reaction would shift to backward. And when you increase the temperature, this is for like the next upcoming P by Q, if this is repeated. When you decrease the temperature, the reaction shifts forward. Now they have asked us, can you see now what they have asked? They have asked increased temperature, right? So when you say increased temperature, then reaction would automatically shift backward. So shift backward, a reaction is favored. Can you see D option is correct? Now this can be asked again in the upcoming P by Qs. So mark this again important. So when I'm marking this question important, that means you have to solve this question second time again. Okay. So at least solve this question at least 3-4 times before your paper. You'll be highly strong in this points. So this matrix goes again valid for this questions. All questions are similar to forward and backward reaction. You can solve by exothermics. Temperature increases, shifts backward. Temperature decreases, shifts. If temperature decreases, the reaction shifts forward. Okay. So now this question belongs to the pH category. Now read out the question again. The equilibrium chapter, right? No, this pH is thermo, right? So pH questions, mixed questions are there. Okay, so even these questions are repeated in salt analysis also, which is an advanced topic. I'll be clearing in that in the lecture itself. The question states that equal volume of 0.5 normality acetic acid and 0.5 normality sodium acetate are mixed. What is the pH of the resultant solution? pKa value of acetic acid is given to you. Mind it. Any question of the pH formula, if they have given you one acid, can you see there is one acid, acetic acid? Decipher the knowledge from the question first, right? First find what is given to you. They have given us acetic acid, right? That is CS3COOH. They have given you sodium acetate, CS3COONA. One weak acid is given to you, and one salt is given to you. Everybody knows this is a buffer solution. Any question of a buffer solution comes, a buffer salt, sorry. I've written buffer solution, buffer salt. Any question of buffer salt comes. This is a direct formula of pH. Buffer formula. You can even name this buffer formula. That is pKa value plus log salt, concentration of salt divided by concentration of acid. Now pK is given to you, that is 4.75 log salt Can you see salt? Is it given? Salt concentration is given to you. That is point 0.9, point 0.5, right? Point 0.5 normality. And again, this is acid is even given to you 0.5. It's a very easy question. This is even cut. Log 1, you can solve the answer log 1, 0, right? Answer is 4.75 itself. Again, very important question, but this can be repeated. pH question can be highly repeated because you see 2018, 2019, 2021. These questions of pH are repeated in different ways. So mark this important. Yes. So this, let's go to this 134th question. The question states, what are X and Y respectively in the following reactions? X plus D2O gives you C2D2 plus P. Y plus D2O gives CD4 plus Q. They have asked us X and Y. This question belongs to hydrogen chapter, right? They have asked in the deuterium form, isotope of hydrogen, right? So they have asked right now in deuterium, but they can ask in hydrogen form, even in the tritium form, hydrogen, deuterium, tritium form, even. Very easy reaction. This you have to learn. Okay, I can even tell you how to do this. Very easy. Al4C3 plus 12D2O would give you 12D2O would give you right. Let me tell you first this one. Aluminium C3 plus if suppose this question is given to you wait if this suppose this question is given to you as H2O, how would you solving this? You will be substituting OH right there. So AlCOH whole thrice. And if I give you if I give you any compound, like if I give you calcium Ca2, right? So again, you'll be substituting OH again to this side. It's a very easy way. AlOH whole twice, right? This is a preparation, right? So how can you solve this question now if this they have just replaced, right? They have just replaced deuterium as in the place of hydrogen. So it's pretty easy to solve again. So aluminium plus OD whole thrice would give you 3D 3CD4, right? Because they have given us CD4, right? This is a balance equation. This you have to learn if you can learn. Otherwise, this is a pretty easy question to eliminate the options that you can always go for, right? Second reaction of aluminium, and then that's of aluminium, that's of carbon. Okay. So can you see carbon aluminium relation is somewhere? See here, right? So you can take now this CaCO2. So CaC2 plus 2D2O would give you CaOD whole twice plus C2D2. They have already given you hint C2D2. So this you are getting and this you are getting as product. You can see this is correct option, right? So you can even solve this, you can even learn this, you can even eliminate this. There are high chances of again repeating. So hydrogen, you must remember. Okay, I'll be completing in the lecture is single. So don't worry, everything will be considered here. You can, if you want any question, again anything, you can always comment in the pin box, right? Comment box. Let's go to this part. Question states MgSO4 is readily soluble in water. The greater hydration enthalpy of Mg2 positive ion overcomes its lattice enthalpy, right? So solubility, this question belongs to again solubility parts of S block. Again, you see S block is going to a good weightage. So any question of solubility comes. I bet in the whole YouTube, nobody would have told you this kind of tricks. So any question of solubility comes. So when the teacher would tell you the lattice enthalpy method and hydration enthalpy method, I'll be telling you one very quicker way to find solubility of any compound. That is larger ions are what? Always remember. Larger ions are generally polyatomic. carbonates, nitrates, sulfates, ClO4, 2 negative, and even iodine. Iodine, you can learn this is big in size, right? So generally they are polyatomic, everything big is here, right? And smaller ion, you can always learn. Smaller ions are what? S block, S block, fluorine, oxygen, and OH. These are always smaller ions. So how you'll be doing solubility? Trick is that the difference between larger and smaller ions is always greater than solubility would be the larger and smaller ions difference. If it is always greater, then solubility is always high. If the difference is smaller, if you consider larger, difference would be small. Smaller difference would be high. So solubility would be high, right? And always, like magnesium and sulfate. Now let's read out the question. Magnesium, magnesium down the group size increases, right? So magnesium is in the group period number 3, right? And this belongs to group 2 element. So magnesium is like small in size. Sulfate is now, you see, I've made in the larger, is large. So this difference is high. So solubility would be high, right? So if solubility is high, so solubility is high, that means this is readily soluble in the water. The greater hydration enthalpy of Mg2 positive ion is overcome its latest enthalpy. Yes. So whenever there's other explanation to this question, that is you can write this, that if solubility is always proportional to hydration enthalpy divided by lattice enthalpy. So if hydration enthalpy is high, solubility is high, right? So you already know that MgSO4 solubility is high. That means that would have high hydration enthalpy, right? Less like this lattice enthalpy, right? So the greater hydration enthalpy of Mg2 positive ion overcomes its lattice enthalpy. I already told you solubility is high. That means hydration enthalpy would be high. So both are the correct explanation, and assertion is the correct explanation. Reason is the correct explanation of the assertion. The A goes fit into the question. So okay, let's go to the next question. Now NaNO3 Xa plus Yb, right? So NaNO3 Xa plus Yb. Again, you're heating this. You have to learn this equation. This is again from S block. The question, this you have to learn the reaction, but I can tell you one trick. Trick again. Every question I have a trick. And this question is repeated in many ways. Again, this is repeated in 2020 paper, 21 paper, you can see. Even in the J, it is repeated. Okay. So trick is that, firstly, I'm telling you the reaction that you have to learn, but I'll not tell you the method to learn. I'll be telling you one trick. You can remember, you can do any question of this. Any NO2 plus half O2. This you have to learn the reaction. But if you are not able to learn, I'm telling you one trick. Trick goes, the one who has low phi means, the one who has low phi means the photosensitive metals. So if you talk about photosensitive metals, so cesium positive has a high photosensitivity, then rubidium positive, then potassium, then sodium, and then somewhat lithium, right? So this is the order for phi, right? So the one who has a low phi, the one who has a low phi would give you on heating, when you heat this, the one who has a low phi on heating would give you metal nitrate plus oxygen. The one who has a high phi, the one who has a high phi would give you metal oxide, high Phi would give you metal oxide plus O2 plus NO2, right? So now question has talked about sodium. Sodium is a low phi. So if it is a low phi, then all obviously you will be following this relation, right? So this will give you any NO2. Can you see this? That's half O2, right? Even balance. This is similar way, right? So which option is correct? A option is correct. So let's go to the next question. And this is S block. Can you see how many questions are repeating of S block? This block is going to be a very, very important chapter. It's very short. There is only two group and only theories, right? So if any doubt, I'll be planning a lecture. So don't worry. I'll be explaining everything from very basics to advanced. So don't worry. I'll be helping you throughout your exams. So when you talk about this question, what this question is stating, they're talking about boron family, right? Okay, wait. This belongs to group 13, not S block. My bad. As I have not seen this. This belongs to group 13 elements. Eventually, the P block, right? S block, P block, D, and F block all are important. The block chemistry is important. So boron family, boron is high. Boron has boron has high melting point. This effect you have to that. Even I can tell you the number that is nearly 2352 if I'm right. Yeah. Uh, this is small in size. Boron, down the group size increases, so boron is small in size. So obviously this is small in size. That would form covalent character. I already told you in Kazan's rule, right? So you can see this question is linked from there. Form covalent, covalent character. So covalent character is there. Now density. Now let's talk about density. Density increases from boron to thallium, right? Boron, aluminium, gallium, indium, and thallium. So boron to thallium density increases. Okay. Electrical conductivity, always everybody knows electrical conductivity. Electrical, this is a non-metal, right? Electrical conductivity. So this would obviously be a bad conductor. So now now what the fourth option states, B10 isotope of its high ability to absorb neutrons. So B10, it's basically the isotope, right? So boron, like let me write this: 1 point, second point, third point, fourth point, and the fifth point. Fifth point is boron 10, right? B10. It is a good neutron absorber. It is a good neutron absorber. Neutron absorb good neutron absorber if you consider B boron 11 isotope, right? So that is nearly like low. That's a low cross section of neutron absorption. Okay, so B10 as comparison to B10 and B11 isotope, B10 has a good absorber because I can make you right. Remember the reaction also. B10 plus one neutron would give you boron. The neutron would be 11. So can you see the options now? It has a high melting point. We already studied. This is correct. It has high density. Boron has a high density. Uh, Boron has a high density. No, it has a low density. Can you see? Boron to thallium density increases. So this option B is wrong. And third option, it has a high conduct. This is again wrong. So this is saying isotope. Yeah, it is correct. So first and fourth is correct only. Yeah. So D option is correct. Again, this is very important question. See, this question has covered your 5 points. Okay. So this is again something very important question. Let's go to the next question. So which of the following Which of the following tetrahalides does not exist? Again, this is a question comes from block chemistry, the carbon family, right? So full carbon family is carbon and even some nitrogen family. Okay, so that is covered there. This question is a repeated question. Even this question is repeated in J. So again, important question. PbI4, CCl4, SiCl4, and what next? PbCl4, right? PbCl4. These four options are given to you. So when you talk about this, does not exist. Any question that comes as does not exist, you have to always see for inert pair effect. So the question would be solved with inert pair effect. Now, how will be solving this? Inert pair effect. Pair effect. So when you talk about carbon, silicon, germanium, tin, lead, right? Carbon, silicon, germanium, tin, and lead. Down the group, what is inert pair effect states? Down the group, always and always. Down the group, stability of lower oxidation state increases. Okay, so when you talk about down the group, stability of lower oxidation state increases. Carbon. When you talk about silicon, right? When you talk about silicon shows +2 even, silicon shows +4 even, right? Germanium shows germanium 10, and then if you talk about this even shows +2 and +4. Two oxidation states are possible, right? You can find maximum. This is the maximum oxidation state and the minimum and maximum +2 and +4, right? So when you talk about +2 and +4, I told you down the group stability of lower oxidation states increases. That means +2 would be highly stable than +4. Okay, so when you talk about, now let's cross check options. CCl4 is given to you. CCl4 always goes, this carbon is in the first, first period, right? So carbon is the second period. So it's like in the first element is there, right? So right now the +4 would be highly stable because this is upside. Then silicon again +4 would be stable. Again, this is not, this says this would exist, right? This would still exist. This will even exist. PbCl4 would, then you talk about PbCl4. Let's leave for 1 minute. PbCl4 would even exist because chlorine has a, little bit high size than iodine has a high size than chlorine, so this would exist. Now, when you talk about PbI4, this one reaction for PbI4. PbI4 breaks into PbI2 plus I2. What is PbI4? PbI4 is in +4 oxidation state. You can calculate that x minus 4 would equals to 0 would give you x equals to +4, right? So lead has +4 oxidation state. Can you see it is reducing? This is strong reducing agent, SRA. This is reducing to PbI2. Can you find the oxidation state? X minus 2 would give you 0 equals to x equals to +2. This is +2. So +4 is breaking to +2, right? So +2 is highly stable in inert and due to inert layer effect. So this does not exist. Okay, so PbI4 would not exist. PbI2 would exist in case. So PbI2 would exist. So I even tell you whole process. Okay, so some teachers would not tell you this inner things, but I'm telling you everything. Okay, and let's go to the next way. Okay, so the correct order of acidity of the following question. Now this question comes from phenol chapter. Okay, the acidic portion. Now, mind my voice, everybody, my aspirants who are preparing for this exam, preparing for J exam, preparing for the NEET exam, any engineering and a medical exam. I can tell you that this question can be repeated as many as times that you can not even imagine. The acidity is the topic which is highly, highly, highly highly talk, right? When I'm talking 4 times highly, then this would obviously be coming. Acidity. What you know about acidity? Acidity always and always inversely proportional to plus I and plus M, mesomeric and inductive effect. This is one relation can solve numerous questions, n number of questions you can even solve. Now you talk about plus I. Let's talk the stability, right? Stability of a conjugate base. So when you talk about this CS3, okay, this would show maximum plus I effect, right? So this would show the plus I effect more, right? So plus I effect would be shown by this. So this will release some electrons. So this our conjugate base would highly be unstable. So this is electron releasing group. Okay, CS3 is electron releasing group, the one who is releasing electrons. Okay, so when somebody is releasing electrons to phenol, so they are making it unstable, right? So conjugate base is becoming unstable. Unstable. When you talk about this OCS3, methoxy, oxygen as a lone pair. The one who has a lone pairs. Always remember the short trick. The compounds are the one who has a lone pair and that is attached. If that is attached to the ring, right? The one who is a lone pair attached to the ring, that always goes for plus M effect. Okay. So this phenol, now A option phenol. So can you see this is not that much unstable? So this would have high acidic character, right? So first would have high acidic character. Now let's talk about plus I. Plus I is more dominating than plus F. Okay, and that is inversely proportional to 1 upon acidic, right? Acidity. So plus I is CS3 is unstable, making it unstable. Then second would be then, and then it would be third, because third would, why? Because third is at the back, because I told you plus I is more dominating than plus F. Both are decreasing our acidity, but still the order goes in this way. So C is a correct option. So phenol would have higher this this acidity, and then this comes to CS3 group and then methoxy group. Okay. So yes, we were discussing question number 121, and the question is from atomic structure. The question states that if delta x is the uncertainty in position and delta v is the uncertainty in velocity of a particle, and they both are stated that they are equal, the correct expression for uncertainty in momentum for the same particle is. Uncertainty questions are very frequent in the EAPCET paper, JEE paper, and even in the NEET exams. So there is one question expected every year on the uncertainty paper. So like there are 6 to 7 shifts of EAPCET papers, so you can like easily get 3 to 4 questions on this particular topic. So what uncertainty states to us? Uncertainty, Heisenberg was one scientist. So he stated his uncertainty principle. Uncertainty principle. What he stated that you cannot exactly find the position and momentum of a particle at the same time, or you can say more precisely, both of these two things you cannot find exactly. If you will find one, for example, if you will find position, the momentum would change, and if you will try to find momentum, the position would change. Okay, so the position and the momentum, both things are very uncertain, and vice versa is always true. So what his an uncertainty principle states to us, he says delta x, which is change in position, to delta p, which is change in momentum, equals to constant h over 4 pi. This is what uncertainty principle of Heisenberg stated to us, where delta x is position and delta p is momentum, right? And h is a Planck constant and 4 pi is a constant again. So now, according to question, what he has stated to us, he stated that delta v is the uncertainty in velocity, and the particle delta x is the particle, they both are equal in nature. For example, like that's delta x equals to delta u, already given in the question to us. So when this is particular case is given to us, also like delta p is change in momentum is equals to m into delta v, mass into velocity, right? M into delta v. That is the formula. So when you'll try to figure out this formula, you can now easily replace things with that. Delta x is delta u already given. So you can write already given. The correct approach for these kind of question is to write first what is given and what is asked, right? So this is given and they are asking us to asking among the relation among these four options. So now when you try to substitute this particular delta p, so delta x equals to just a minute, delta x equals to and delta x dot m delta u equals to h over 4 pi, and you can easily get delta x equals to delta u, or you can say delta u, right? Delta u or delta v, right? So both are velocities only. So in this case, that is already given equal to us. So you can replace this one x with a u. So delta u m delta u equals to h over 4 pi. And now what you're getting as answer, m dot delta u whole square equals to h over 4 pi. And now you can easily get like delta u is equal to under root of h over 4 pi m. And if that is the answer coming to us, and then delta u, and now that what he was asking to us, can we live back to the question? They're asking us change in momentum, right? So you'll be multiplying an extra mass to it. So if you multiply m both sides, multiplying m both sides to get momentum, because momentum is the product of mass into velocities. So you already got velocity, now you need to multiply m to it. So what you will be getting in that, m delta u equals to under root of h m over 4 pi. So delta p is your this relation, h m over 4 pi. Let's look into the option which is the correct option to it. H m over 4 pi would give you how much? That's exactly h over this one. D option is the correct option. No, wait, D is not the correct option. That C option is correct option. Actually, that's H m over 4 pi. So you can take 2 out of 4, you can make 1 by 2 outside. So that what you are getting as H o m over pi. Exactly matching with option number C. So also we are now discussing number 122 question. Again, the question is from atomic structure. So you can see atomic structure is highly weighted topic when you talk about either chemistry or you either talk about physics, because atomic structure is something which is used in the modern physics itself, right? And even in the chemistry at chapter number 2 of the NCERT. So the question states the number of radial nodes, angular nodes of 4f orbital are respectively. Very common and a very frequent question in the radial nodes. So now let me tell you, the question has already given us 4f. So let's write this for 4f. They are asking us to find. So 4f. So whatever number is like here, so that is n, principal quantum number. That's already given. 4, and you need to find 4 is already given to us, right? And how you find L? L is n minus 1. So very easy. You already know this one, and you already got to know n minus 1 would be L. So that's 4 minus 1 would be 3. That is your L. So what is the formula of radial node? Mind my words. This formula is very important, and you can expect 1 to 2 questions. If you're lucky, you would get this question back to your upcoming exam. So n minus 1, L minus 1. This is the formula for radial nodes. Already you are given with the principal quantum number, that's 4. You already know 3, and 4 minus 3 minus 1 would give you 4 minus, that's exactly 0, right? So they're asking us what they're asking us, if you'll be they're asking us, you can check now, number of radial nodes, which is coming 0, and angular nodes. So angular nodes are already your L, basically. So that's 3. So option number A is correctly matching with the question. So very easy question again. Now let's look into question number 140. We were on 140 question. So yes, this question, 140 question is from General Organic Chemistry, GOC. Important portion, highly weighted topic in organic chemistry. The question states the compound or ion which is not aromatic in the following. 4 options are given. Yes, important. I will be telling you a very good short trick for this particular question. How we do this such kind of question? It's particularly from GOC, the aromaticity topic. And this question is very frequently asked in every paper, not this paper, but every exam agencies which are conducting. This paper is very often, this question is very often in that exam. So how you check aromaticity? There's a Huckel's rule. Student often gets confused in Huckel's rule and finds it little bit difficult, right? So Huckel's rule, I don't suggest you to follow Huckel's rule actually, because without this even you can solve the question. So how will be solving this particular question without Huckel's rule? So let me tell you the method for the aromaticity. There are two compounds, aromatic and non-aromatic, right? AA, anti-aromatic and aromatic. And the other one is non-aromatic, right? So aromaticity consists of anti-aromatic and aromatic. What is the condition to be aromatic first? You tell me. There are 3 particular conditions. It should be non-planar. The atom should be sp3 hybridized. And the third rule is it should follow Huckel's rule. That means cyclic conjugation must be there. So this 1 and 2 are always fitting into the system, and that is aromatics. You can see option A, option B, option C, option D, all are non-planar as well as sp3 hybridized. So these first 2 options aren't that important. Every question of aromatics generally follow this trend. But when we talk about Huckel's rule, right? So how you solve with Huckel's rule, without Huckel's rule? So there is a trick now. If your conjugation would be the multiple of 4 of 4, then that particular compound is anti-aromatic, AA. And if it is a multiple of 2, or you can say other than 4, right? So multiple of 2, that particular compound is non basically aromatic. My bad. See, when you talk about non-aromatic, that means this particular condition should not follow. But you can see all 4 are following this non-planar sp3. So you need to know the Huckel's rule. And Huckel's rule, aromatic, if it is coming the multiple of 2 basically, then that particular compound is aromatic. So we have to tell which is not aromatic. Just have to underline it is given non. Student often tends to find like answer and then they confuse. So let's look which is multiple of 4 to go for anti-aromatic. You see, 2, basically you count electrons. One bond has 2 electrons. So 2, 4, 6, right? And then that's 6 and then a lone pair in nitrogen. So 2, 4, 6, 8. So it is a multiple of 8. Now let's look this option. 2, 4. And now let's look this option. 2, 4, 6, 8, 10, 12, and 14. So multiple of 2, 2, 4, 6. 6, right? So how will you be checking now? Now see, which is fitting with our system. 2, 4, 6, right? So now if you look in the option number B, it is actually the multiple of, you get multiple of 4. So that would be the very correct option to match, actually, right? So always remember, if it is anti-aromatic condition, if it is 4, 8, um, 12, 16, these kind of numbers. And for the aromatic, if it is 2, 6, 10, 10, 14, basically multiples of other than 4, basically you can say other than 4 would always be considered as aromatic. And aromatic, and for the anti-aromatic, all the multiples of 4. Okay, so yes, option number B is a very correct answer to the question, right? Oh wait, like this is 6. I just wrote this down. This is actually 6. 2, 2, 4, 6. So yes, you see, this is only the multiple of 4. So option D is a very correct answer to the question. Now let's look into the question number, next question. That's 141. Yes. So again, this is from solid state. The physical chemistry chapter number of the very first chapter of 12th class. The number of network solids and the ionic solids in the compounds. Yeah, the number of network solids and ionic solid in the given below respectively. H2 they have given us Al, they have given us copper, Cf2 fluorspar, this is an ore. We'll be starting itself in chemistry. Diamond, MgO, CCl4, ZnS, England, Ag, NaCl, SiO2. So these compounds are given us, and they are asked us for the network solid number and how many are ionic solid. This you have to learn basically. Network solids are the one who forms network. Yeah, that's easily predicted. So network solids are, let me name them. That is your diamond. Even you have to learn this. Learn diamond, SiO2, and Aln. These are three which are there as a network solid. So ionic solids would be the one who forms ion. Mg like you can break this ion. You can even break this NaCl, Na positive, Cl negative, Ca2 positive, and F negative, right? CF2. And then ZnS could be even, you can even break this in the form of ions. So how you can count like 1, 2, 3 are in network. And so this A and B among would be the predictions, A and B. And now ionic is 1, 2, 3, 4. So 3 and 4. The B option is matching with the question. So let's go to the next question. That's 142. So again, the question is from solid state. Again, solid state is going to the high weightage nowadays. So yes, we cannot ignore at least these kind of topics, because these are very pretty easy topics to secure very good marks in the exams. So the question states that if molten NaCl contain SrCl2 as impurity, crystallization can generate. So this question is from vacancy. So every year vacancy is a topic which you can easily predict questions. Defects and vacancies are two important topics in this chapter. So yes, how will you be solving what they have given us? They have given an NaCl and they have given us SrCl2. So when you be finding the oxidation state for the SrCl2, you would be getting Sr2 positive, right? So X minus 2, chlorine has minus 1, like electronegativity. So minus 2 equals to 0, X equals to plus 2. So that's what you're getting, x equals to plus 2. So when you're getting this particular x equals to plus 2, so that is SR2 positive. And how you can break Na positive and Cl negative? You can easily break N into Na positive, right? So now look into the question. For 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 SrCl2, actually, for SrCl2 to replace, you need 2Na basically. So 2Na would only combine with Sr2 positive, right? So if I make 2Na, Na positive, Na positive, and Sr2 positive, right? So write this, each Sr2 positive replace 2Na positive ions. Because you see there is two positive charge to, to balance it, you need actually 2Na exactly. So Sr2 positive occupies the side of one Na positive ion, and the other remain vacant. Is it? So if you combine this particularly with one, right, to balance this, so you will be left with actually the other Na positive, right? So this particular Na positive would be having a vacancy. So the correct option, Na positive, is in a cation, right? So this would have a cationic vacancy. You can see option number B is a very correct answer for the question. So yes, again, this is important part. Each Sr2 positive replaces two Na positive ion. Sr2 positive occupies the site of one Na positive ion, and the other remains vacant. Exactly what I have told you. Now let's look to the next question. So again, this particular question is from physical chemistry, right? So this is from the colligative property. Colligative properties, five colligative properties: depression, freezing point, elevation, and osmotic pressure. All these four, five colligative properties are very important as per the exam point of view. You can expect every time one question from this physical chemistry. At least from five physical colligative property, I bet you can get one question in every shift. So now, what the question is stating to us, let's read this question with me. So the question is saying, at a temperature, they have given us something for a non-volatile solid. Molar mass is already given to us. When added to 0.5 water, 0.5 kg water, lowered its freezing point by 1 degree Celsius. What is X in gram? Kf for the solution is already given to us, and temperature is already given to us. Easy. So that sounds easy, but that's not too easy, when you try to solve this particular question. So what is the correct approach for this formula? There is one formula for the, for the freezing, depression in freezing point. There's one formula, Kf dot molality, right? So they have asked us what they have asked us. Read the question. They have asked us nothing but the grams, right? What is X in grams? The solute, mass of solute, they have asked us. That's unknown to us. So there is one particular way you open this molality formula: number of moles of solute divided by, number of moles of solute divided by mass of solvent in kg. So that is the formula for molality. So you can go with this particular formula, and if you will be splitting number of moles of solute into, number of moles of solute, you would be splitting into given mass upon molecular mass. So you can easily get that given mass, basically given mass upon molecular mass, and then you can easily get this with this method. But this sounds very, very boring and very, very long too. But let me suggest you one quicker formula and you can solve any numerical on that. That is already not a short trick, but the expanded formula of this, which some students don't know, but you can learn this. That's that's particularly, yeah, that's WA into 1000 into KF divided by molecular mass, that is of solute, and even this is of solute, multiply by molecular mass of solvent. This is a short trick formula. Directly you can apply. Just have a. You can even open this formula and you can solve again. But this would sound more often because this would help you directly in solving the unknown values. So how you split this? Freezing point TF minus T initial, right? So now when you look into the question, they have already given us in kg, right? So we don't need 1000 now. So how will I, edit this back? That's particularly you don't need 1000. I'm just canceling it because wait, yeah. Oh, never mind. Let's do it again. So that's delta TF equals to WA into that's 1000 because why we are not taking 1000 because mass of solvent is in kg and that is already given to us. So when that is given in grams, then you need to multiply 1000, but that's not the case. That's already given. So WA into KF, but when that's given in grams, you need to multiply 1000. So molecular mass of solute into weight of solvent. That's in kg. Well, mind my words, that's in kg, then only you'll be applying. Otherwise, if it is in the grams, then in the numerator, you need to multiply 1000. So now that's easy. TF, this you can say TF minus T initial, TF minus T initial. So TF is already 1 degree to you. You can see in the question that's already given, lowered by 1 degree, 1 degree. Initial would be 0 degree. So now let this weight of solute be x gram. So x into Kf is already given to you 1.86, and molecular mass of solute is even molar mass is given to you 78 grams, and 0.5 for the weight of solvent is given to you. So you can just find this x by solving. You would be getting actually 78 into 0.5 over 1.86. So after solving x, you would be getting as 20.96 grams. Again, this is important question. Don't be surprised if you are the student of J even. So this question is even asked many times. Okay, to find the unknown. In 2021, you can look into the previous year question. They've every time given this x to find this unknown x. So just directly learn my shortcut formula that would directly enhance your performance. So this is the particular formula you need to learn. Yes. Let's look to the next question. So next question is from basically the biochemistry, right? There's a one chapter biomolecules. If you name the particular, that's in 12th grade. So this question is from that particular topic. No, wait a minute. That this question is from surface chemistry. Actually, I've seen blood cells, so I was confused. So this is from surface chemistry. Surface chemistry. There's one topic, osmotic pressure. So let's read this question line to line. Blood cell collapse with suspended in saline water, and the reason they have given is cell membrane dissolve in saline water. So let's see what is how we solve. So blood cell. So when like anything about saline water is salt water, right? The salty water. And when you talk about salt water, this is an hypertonic solution. I hope you guys know hypertonic solution. What happens in hypertonic solution, I'll be telling you. This is particular is a hypertonic solution, and there is a cellular fluid given to us. Like if it is a hypertonic solution, that means there are, there are more solute particles are outside in the salt water. Because you see, they have already suspended in a saline water. Saline water means that salt water is outside and this blood cell is inside, right? So outside salt water is there. That means more solute particles are present in comparison to inside, right? Or we generally give this question with the cytoplasm, right? So there will be what will happen. So the saline water, basically the inside you see blood cell. So water will move out of the cell. Water will move out of the cell, and that particular process is known as osmosis. So osmosis, if somebody asks you, the movement of solute particle from inside to outside is basically the osmosis, right? So due to this, a concentration gradient and the cell, which is blood cell, if water will move outside the cell, okay, somebody, for example, if I take all your water from your body, so your body would start shriveling, right? You will shrink in the position. That's a hypothetical case, although. But can you imagine that, if you decrease the concentration, the cell will shrivel. So so in this particular case, due to osmosis, the cell would shrivel. But what they have given us a reason as, this particular case is happening with due to osmosis. Yes. So that particular case is happening with osmosis, but they have given reason as cell membrane dissolve in saline water. No, it doesn't dissolve. So a both a assertion is correct, reason is false actually. So even not the correct explanation. A cell membrane dissolved in saline water is a correct way, but like it's not a correct explanation for this particular question. So hope this B option was correct to the option. Also for the extra knowledge clot, I can even tell you one thing. Like there was question asked in the PYQ even, water no longer, no, I just mark this as a star. Water no longer enters at this point. When water cannot enter back, right? So that particular pressure, that turgor pressure, is known as osmotic pressure. So what is osmotic pressure? Basically, when water can no longer enter to any point to the cell, either or to the saline body. So that particular pressure is known as turgor pressure or the osmotic pressure. So let's go to the next question. Yes. So electrochemistry question, again, the important one. Actually, like when you talk about this particular question, the question is from electrochemistry, but also from the Nernst equation. So Nernst equation is something which is again important for the exam point of view. Every year, 1 to 2 question can be asked in this particular topic. So let's go and read this particular, points. The reduction potential of hydrogen electrode is already 25 degrees Celsius in a neutral solution. They have already given us concentration, that is 1 bar for the hydrogen. Hmm? So when you talk about hydrogen, H2, how can you split hydrogen? You can make, if you do a reaction, that would give you 2H positive plus 2 electron equals to H2. That's how you make H2O, H2 hydrogen. So can you see the change in number of moles is 2? So what is the Nernst equation formula? EMF of cell equals to E naught of the cell minus 0.0591 divided by N log product concentration divided by reactant concentration. So P by R I'm writing. So can you see the change of number of moles is already 2? You know, 2, there is one coefficient 1, so 2 minus 1 is, 0. 2 minus a 0 is a 2, right? So that's, and there is no change. Oxidation for this particular is 0. So there is a change of 0 to 2 minus 0 is 2, right? So E cell, inert cell of hydrogen, right? They have given us hydrogen question. So remember, always hydrogen E naught is always and always 0.00 volts, right? So it is 0.00 volts. So that would come as 0. E naught cell would be 0 minus 0.591 divided by 2 log. What is the concentration of product? So the concentration of product is already given to us. That's 1 bar. Reactant concentration is of H positive. So H positive, and the coefficient for that reaction is 2. So that would be multiplied actually with 2, the power raised to 2, right? So now how you'll be solving this question again? Now, if you make this up, so that would come as what? 0 minus 0.59 divided by 1 over 2 log H positive minus 2, right? So this minus 2 would come out of the bracket, the property of logarithm. So I'm solving this again here. So that is minus 0.59 over 1 over 2 log, that's minus 2 basically, right? So minus 2 log H positive. So this is what you're getting. Log H positive is nothing but a pH, right? So this is pH. So this would come as, if you cancel this would come as minus minus plus, answer would come as 0.59 pH. The unit would be pH. So let's recheck the options. What is given to us? That's given in volts, but like when you need volts, so something like you need to know the concentration of even H positive. That's not given in the question. So like option you can change. If this is the question, if this is the particular question, so option would match to the A option, but the unit would come at 0.059 pH, right? Because that's log H positive, right? So if this is a particular question, either if that is in volts, so they should have given the concentration of H positive ion also, right? So then only you will be getting answer in volts. But right now that's not the case. If this question is in this way, you can solve in this way. So option A is matching, and you can correct the options. Yes. So let's go to the next question. Now, again, rate of reaction kind of question from chemical kinetics. Let's read this 146 question. The question states the rate constant for zero order reaction A, that gives product is already given to us 0.030, right? So how long will it take for initial concentration of A to fall from 0.10 molarity to 0.075 molarity? Now this is zero order reaction question. So they're asking us time. So for the time formula for zero order reaction, everybody should know. Important. You can mark 3 importance actually, because this is seriously important. Now you can expect again this question. 2019, 20, 21, and now all the papers of 22. This similar question you will see in the last shift also, right? So this is something very important question. So for zero order reaction, how you go for solving? That's K equals to A naught minus AT, you can say even, divided by T. Initial concentration minus final concentration divided by time is a constant K. So they have asked us to find time. So A naught minus AT divided by T. So A naught is already given to us, right? The initial concentration is already given, and the final is even given. So from they're asking us to subtract 0.10 minus 0.075 divided by time. No, they have asked us divided by k, right? This is k. So when you divide this by k, so what is your k? Your k is 0.0030. So after subtraction, you can easily get the answer. K would come as 0 point, like k is 0.03, and a naught is already given to us this, and et is even given to us this. So after solving, you would be getting 8.33 seconds. That would come in negative, but time could not be in negative, so you'll be holding a positive value. So time is coming as 8.33. So 8.33 would be C option, matching with the answer. Yes. So let's go to the next question. Again, the theoretical based surface chemistry itself, your paper consists of 3 questions. You see, from the surface chemistry only. So again, surface chemistry, collision, colloidal particles topic is important. Let's read the lines. The diameter range for the colloidal particle is approximately this. Very first page of NCRT, you can find the sizes table, and you can learn. For that, even I am just telling you for the others even. For there are three kinds of solution: true solution, colloidal, and other one is suspension. Everybody have studied in the ninth grade this particular chapter, suspension. So true, colloidal, and suspension. So I'm also telling for not just colloidal, I'm just telling you for true, but true even less than 1 nanometer. Less than 1 nanometer is a range for true solution. 1 nanometer to 1000 nanometer is a range for colloidal, and more than 1000 basically, right? So more than 1000 is a range for size of suspension. So now, right now, they have asked us collider only, but they can ask true solution also and suspension also. You would not be surprised if they ask this question back, right? So A option is matching with the answer. Let's go to the next question. So photographic plate are prepared by coating emulsion of which of the following in gelatin? Again, the question of surface chemistry mixed with a little bit, on the biochemistry one topic, gelatin is there. So, but yeah, this is purely from surface chemistry. You can say surface chemistry, surface chemistry. Yes. So, how will you be solving this surface chemistry question? You know anything about photographic plates? These photographic plates, which we use generally in the televisions, even in the photos, even, right? This photo, the cinemas halls goes for photographic plates. Photographic films are prepared, right? So how they prepared films, right? They prepared by the coating of emulsion of the light sensitive metal, and that sensitive metal is nothing but AgBr. Okay, silver bromide is a metal, basically an iron, that is used basically, in gelatin, or even in the celluloid films. So this is where used, right? This is used in the films industries, photographic films, even black and white in the earlier times. You when you coat this, you can easily get, when the light falls on this surface, the exposed part of that particular film is darkened. So that's why you get black and white images. So that's how they are used in black and white photographics. So AgBr is a particular iron which is used. So you have to love this. right? So I've given you much details on this particular question. I hope if it repeats, you will be able to solve this. Let's go to the next question. Again, the question is from particularly block chemistry, P block chemistry, right? So the question has given us a following reaction, and they have asked us the balance equation. If you ask this question to do a question of 10th grade, even student can solve this particular question. The question is very, very easy. This under 1 minute question, right? So we don't have to waste a lot of time in under 1 minute. So you need to practice a lot question on this particular topics. This is a reaction, and even you can learn this reaction. Oxides, basically this reaction comes in oxide. I'll be teaching in the chapter itself. So Pb3O4 gives you PbO plus O2. So when you try to balance this, okay, so when you try to balance 2 here, so this is 3 to just 6, 3 Pb, right? So let's like 6, let me mark 6 here. So you get 6 Pb. Let's check oxygen, 4 to just 8 oxygen, 8 oxygen, and 6 plus 2, 8 oxygen. So 2 comma 6 is the answer for this question. B option is matching. No, D option is matching with the answer. Actually, this was very, very easy question. You know. Now, let's go to question number 150. So 150 question states what? HCl gas is dried by passing through concentrated H2SO4. HCl gas reacts with ammonia that gives white fumes. Again, the question from block chemistry, P block chapter, group number. P block chapter, group number 16. 16th group particular topic of HCl is there. Thereby you can see this. So questioner said HCl gas is dried by passing ammonia by passing through concentrated H2SO. For example, like I'm assuming you don't know anything on this question. How can you eliminate even? HCl gas is reacted with ammonia. Okay, so that gives white fume. So can you see there is no role of ammonia here in the assertion even? So how can you make this reason particular the assertion of this question? So although like you can guess that the reason might not be the correct explanation for the assertion, but let's look the assertion part. So what they are saying, HCl gas is dried by passing H2SO4, concentrated H2SO4. So that's particularly correct. You how you dry HCl gas? HCl gas you dry by passing. HCl gas is dried by passing concentrated H2SO4. Now, when you talk about H2SO4, it has a great affinity for water. You know, there is a very, very high affinity, very, very high attraction for the water. And when it reacts with the compound containing water, it strongly acts as a dehydrating agent. So H2SO4, concentrated H2SO4 always acts as a dehydrating, and concentrated H2SO4 acts as a dehydrating agent when it reacts with the compound containing water. Dehydrating agent. So HCl gas reacts with ammonia that gives white fumes. No, that's not correct. Assertion is always right. You can see assertion explanation is this. The reason is false even. That's not the case. You cannot get white fumes there when you react with that. So assertion A and R, you can see which is A is correct, R is incorrect. C option is matching with the answer. Again, easy question. Just you have to know about concentrated H2SO4 property, and you can easily solve this particular question. Let's go to the next question. The catalyst used in the manufacture of polyethylene is a mixture of. Again, the question from polymer, the one of the underrated topics, right? And this is one of the very underrated topics, but you can now look into a trend of JEE, NEET, EAPCET paper, BITS paper. These, the EAPCET paper of Andhra Pradesh, Telangana, all these papers are now following polymers, chemistry in everyday life to a good weightage, right? So TiCl4, this is a polyethylene, right? So this is basically a polyethylene. So when I talk about this polyethylene, what you know about this polyethylene? This is one reagent is used to manufacture this. That's given in NCRT, right? So when you talk about this particular TiCl4, what you name this TiCl? Just polyethylene. Wait, for the polyethylene, ethylene, right? You use titanium tetrachloride and diethyl aluminum chloride. So these two particular compounds which you use when you manufacture polyethylene, that is TiCl4 and aluminium C2H5 whole twice Cl. That's two compound which you use, and this particular even is known as this particular catalyst are even known as Ziegler-Natta catalyst. Again, as in the PYQ, or identify which is a Ziegler-Natta catalyst. So this is Ziegler-Natta catalyst, right? So right now polyethylene they have given us, so that would be used as CS3. Right now I have for the ethylene they have said, right? So that means that option should be C2H5, but that's not given. So like poly that okay, so we can even get this TiCl4. Just have to replace this with Al, and the C2H5 would be replaced with CS3, right? CS3 whole twice, basically whole thrice. So which is option matching? This is Ziegler-Natta catalyst. For this particular question, let's see which is matching. TiCl4, AlCH3 whole thrice. The option is matching. But they can ask this one more, right? This is asked for, but this is particularly, manufacture of polyethylene. This is a particular correct formula. Ethylene, when you manufacture, you generally use this formula, but they have given in this way, so that's even correct. But the official accepted is this NCRT. You can reread again and again, then you will find this particular thing. So let's go to the next way. Now the next question is, which of the following is correct related to the color of TiCl3, TiS2O whole Cl3? So the question is from coordinate compounds and the inorganic portion. Okay, mind my words, any question comes of paramagnetic, diamagnetic, color question, always have a knowledge about unpaired electrons. Whenever you have unpaired electrons, then only you can anything, then you can comment on this particular question. So how you'll be telling this? How you find this unpaired electron? Titanium, right? Titanium comes as a the uh, scandium, titanium, vanadium, scandium, titanium, vanadium, chromium, manganese, Fe, cobalt, nickel, copper, zinc, right? So how you do the electronic configuration? 4s2 3d1, right? 4s2 4s2 3d2. Wait, 4s2 3d 3d2 for the vanadium, titanium, and 4s2 3d3 for the vanadium. They have talked about titanium. Rest you can even can create like this is an exception electronic configuration, right? And this copper is even exception. This exceptions goes for 4s1. I am just telling you, this is again a PYQ about this particular. So 4s1 3d5 is the exception for this, and copper is even 4s1 3d5. I'll be telling you and I'll be teaching this chapter, the logic behind that. But right now, just we are given with titanium, right? So let's look 4s2 3d3. So titanium, when you do the oxidation state, when you find x minus 3 is equals to 0, x equals to plus 3. So when you remove this plus 3 electrons, so firstly you will be removing electron from s orbital, 2 electron, and then 1, you will be left with 2 electrons, right? So when you are left with 2 electrons, again, now let's go for this one. Yeah, are we getting correct? 4s1, 4s1, 3d2, right? Now, when you solve this particular question, if you find the oxidation state for this, what you be getting? X minus hydrogen has like zero charge because this is a neutral molecule, a neutral compound. So this again, this would give you plus 3, right? So again, X equals to plus 3 charge coming to titanium. So when you are coming this plus 3, so again you remove plus 3 for TiS2O whole 6 whole 3 positive. Yeah, whole 3 Cl3 whole 3, like what you're getting is oxidation state. Titanium is coming as plus 3. So when you remove 3 electrons from 4s to 3d3, so if you remove 3 electrons to first 2 and then again 2 electron, so when there is an unpaired electrons, either unpaired electrons, yes, they consist of an unpaired electrons. So when they have unpaired electrons, so that solution would always be colored. And let me tell you, titanium always comes as a violet color. Okay, this is extra plot for further questions as this question comes. So titanium always comes as a violet color. So two electrons are coming in TiCl3 even, and even this compound also. I'll be even telling you the IUPAC in the following chapter when I'll be teaching. But right now plus two are coming. So they have 2 electrons unpaired. So then you have any unpaired electrons. So mark my words, if they are unpaired electron, the solution is colored. So B option is matching with the question. Colored, X is even colored, and Y is even colored. So let's go to the next question. So 143 question. Let's see what it talks about. It talks about which hormone tends to increase the blood glucose level in human. This is again from biochemistry, right? Biomolecules. So when you talk about everybody's knows, right? Blood, how you like when there's an increase in blood glucose in the human body, so you need insulin, right, to decrease that particular blood level in the human. So there is an increase in the level of the blood sugar level. So the patients are even given the injection of insulins, right? In your family, when you might be knowing about this insulin injection, somebody's blood sugar has increased. You might have heard this particular statement. So why you give insulin? Just to decrease the blood sugar level. So when there is a increase of blood sugar level, where this blood sugar level is, is which hormone secretes the blood sugar level? So glucagon is a hormone, right? Which stimulates the blood sugar level. So if glucagon is increased, that means your blood sugar has increased, so you need to get insulin. So insulin would decrease your blood sugar level. So that's the particular question for the answer. So if insulin topic also comes, you'll be able to solve this particular kind of questions. So 154 question. Let's see what the question state. Which of the following molecules is eliminated during peptide bond formation? Peptide bond formation, again, the question is from biochemistry or like biomolecules, the 12th portion of the chemistry, organic portion. So let's see how you solve this question. This is even a repeated PYQ. In 2019, this was repeated. Let's see how this goes. So you have to make carboxy amino acid for this. There's one carbon, one hydrogen, one alkyl chain consists of one NH2 amine group. Let me rewrite again. Yeah, NH2, and then again one basically one carbonyl group, C double bond O, and then OH to it, COOH, basically carboxy amino acid. So you have to make two balls, two similar structure. You see, this is a chiral compound. Chiral compound means what? Chiral compounds mean all carbon, one carbon has all different valency, different four valencies. Hydrogen different, ammonia has a different group, alkyl chain different, and this particular group is a different group. So this particular compound is a chiral molecule, right? So if consists of four different valencies, then that particular compound is chiral. So let's repeat again. This draw this again. C H and then NH2, right? N hydrogen. Wait, let me write again. N hydrogen with C double bond O and OH to this, and one alkyl chain. So when this is formed, right? So what is peptide during the peptide bond formation? You just have to remove H2O. So when you remove this H2O, so after removal of H2O, even I'm telling you this reaction, nobody would tell you while solving this question, because this reaction could even be asked. So what you remove during form of peptide, formation of peptide, you remove H2O. So correct answer is H2O. Let's look to the next question. Again, this question is from organic chemistry, right? HCl, ZnCl2, these kind of question are given to us. This is question from alcohol, phenols, and ethers, the organic chapter, right? So the second organic chapter of the 12th chemistry. So the question states what? The question state identify the major product formed during the following reaction. So just have given with this particular something OH alkyl chain. So first reagent is given to us HCl and ZnCl2. I'm writing here important reagent HCl and ZnCl2 whenever it is given to you. That means they are talking about Lucas reagent. This reagent is known as Lucas reagent. Generally used to differentiate 1 degree, 2 degree, 3 degree alcohols, right? So that directly depends on the turbidity. So 3 degree gives quickly, 2 degree, and then 1 degree is the order, carbocation order. So like that, I'll be teaching in the itself chapter. For now, I'm just telling you how you solve this, so that if student know little bit even, so he or she would be able to solve this particular question. So how you solve this particular question? Yes, you are given with HCl and ZnCl2. This is Lucas test, right? So how you do this reaction forward? When there is given to you HCl and ZnCl2, you just have to substitute a halogen with an alcohol group. So this Cl is given, so you will be substituting obviously Cl. So you'll be getting this as a result. Now when you do this again, this first is solved to us, right? Now they are using us again second reagent Ni dry ether. Ni again second name reaction dry acetone. This is Finkelstein reaction, haloalkanes, haloarenes reaction. Second reagent they have used NaIA. This is Finkelstein reaction. Name reaction. What we do, we exchange the halogen exchange preparation. It is generally we use sodium iodide in this, and you replace iodide with the particular halogen. So substitution, basically exchange of the halogen. So what you be getting in this I, right? So you got I. Now third reagent what they have used, second you got, now like what they have used is Na dry ether. Again the second name reaction, and the third name reaction to you Na dry ether. This is Wood's reaction. Wood's reaction. How you solve Wood's reaction? Generally, what is alkyl group is given to you. You just what you have to do is just have to double this, right? For example, one, two, three, three carbon chains are given to you, right? So you will be increasing the length generally. So the double would be the answer. One, two, one, two. 3 was given to us, right? 1, 2, 3. And then let's double this 1, 2, 3. So that's the particular answer to this question. So option number D is matching with the result. So this would NaI would come out, right? So when you are solving this chain reaction, you don't have to write the byproducts, right? When you are doing the one particular reaction, then byproducts are necessary. So this can come even in the conversion for the board student, the one who are planning for the boards. Let's go to the next question. Yes. Now the question states for from 156. Again, the question from organic chemistry, and this question is from alcohol, phenols, and ethers. So, what the question has asked, let's see. The question has given us um, when one chlorobutane is treated with aqueous KOH, it gives P. However, when it is treated with alcoholic KOH, it gives Q. Identify the product P and Q respectively. So you know the rule of alcoholic KOH and aqueous KOH. Let me write the rule. Whenever that is alcoholic KOH, you always have to go for elimination reaction. Dehydrogenation reaction. Dehydrohalogenation reaction. And when there is aqueous KOH, when it is written alcoholic, that means you have to do elimination reaction. And when it is given as aqueous, basically dehydrogenation reaction, right? Dehydrohalogenation reaction. And when it is given as aqueous KOH, you have to do substitution reaction. So let's go. They have given us one chlorobutane. Let's make the structure of actually one chlorobutane. So met eth prop-but, one chloro is given to you. Let's not write hydrogen because already that's given in this way, right? So that's not the correct answer. Wait. Yeah, yeah. So right now I'm not balancing hydrogen because right now there is you can save time because this kind of reaction you don't have to balance hydrogen right now. Just assume CCC. If it is butane, propane, just increase the carbon and write what is given to you. That's one chloro. So how you'll be now going? Now for the aqueous KOH, you have to go for the substitution reaction. And it is aqueous KOH. You have to do substitution reaction. The OH would be replaced by the Cl, right? So this would come as C, C, C. Wait, it's getting, yeah. C, C, and C would be replaced with OH. So you see 1, 2, 3, 4 carbons, 1, 2, 3, 1, 2, 3, 4 carbons, right? This is coming as for the aqueous KOH. Now, when you talk about alcoholic KOH, now for the alcoholic KOH, what you have to do, you have to do elimination reaction. How you do elimination reaction? I'm telling you this one trick for that. That's Cl given to you. What you have to do? This is alpha beta elimination, right? So this is alpha position. Just what you have to do, just this is CS3, CH2, 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 Cl, right? CH2, Cl. So for the alpha beta elimination, what you have to do? Just remove hydrogen from the position, right? From the alpha, the next, the halogen, which is halogen, the next position is the alpha. I'm just assuming this alpha and the next one beta. Okay. So when I'm assuming this as alpha, so you have to remove one hydrogen from the alpha position and put the double bond. What would come? CH3, CH2, C H double bond CH2C, CH2, right? Cl would be removed. So that would come as KCl. That's not important. Byproduct are important for this particular reaction. So let's see which is option number matching with, like, which option is matching. So you got two as answer. One is this one and one is that one. So let's see, 4 carbon with a double bond. Yes, this option is matching. You see, 1, 2, 3, 4. This was the answer which we got. So this is what we are matching with the question number, option number D. Yes. So let's go to the next question. Now, 157th question. Identify the major product formed in the following reaction sequence. Hmm. They have given us sequence, and now they have asked us particular format of the question. How will you be solving this question? They have given us the CS3COL anhydrous AlCl3. Mind my words, when they have given us anhydrous AlCl3, also mentioned CS3COL, CS3 SI group. This is a CS3COL is SI group. SI group. So when they give this particular kind of question, how you solve this SI group question? This is Friedel-Crafts acylation name reaction, right? So Friedel-Crafts acylation, only why we add Friedel to that when it is given AlCl3. Otherwise, that would be, whenever it is not a anhydrous AlCl3, then you would be directly writing acylation reaction, acylation reaction. But when it is anhydrous AlCl3, you have to mention Friedel-Crafts acylation. And now second reagent, they have used this particular reagents, and then the third one is this. So let's solve this one by one. This is a benzene, right? Toluene is given to you. This is known as toluene. And when you react with this particularly, CS3COL, anhydrous AlCl3, this is nothing but Friedel-Crafts Friedel-Crafts acylation. So what you be getting in this case, CH, this one HCl would come out, that one hydrogen, right? Out of 3 hydrogen, one hydrogen would come out. So that would give you what? That would, in this case, would give you, right, would give you OCS3. This particular group would be directly attached to that and would give you this particular OCS3, right? So let me write that OCS3, and uh, downside there is one CS3, ortho and para position, right? CS3. Now after this OCS3 and CS3, when you do the reaction with KMNO4, how you solve KMNO4 KOH? Second part is given to us. This KMNO4 KOH, this is the reaction in carboxylic acid when it is methane and a benzene to it, methane. So this particular carbon would directly convert into carboxylic acid. So this would convert into OCS3, would convert into methoxy. This is methoxy, right? CS3 would come, COH would be there, right? So for this, like particular, I told you, when there's KMNO4, there will be a COH. And then they have asked for dilute H2SO4. So this ether would, get reduced again to the carboxylic acid, and you will get answer in this way. One COH here and the other COH here. So which option is matching? Option number D is matching. Also, this is known as phthalic acid. I'm just telling you for extra knowledge. Phthalic acid. This is generally used in, when you'll when you'll be studying phenolphthalein and all those things and organic chemistry. I myself will be teaching you this, but I'll be that time telling you like what is phthalic acid and all. For now, option number D is the correct answer. Let's go to the next question. So nucleophilic addition reaction. Again, the question from organic chemistry, aldehyde ketones. So arrange the following in increasing order of reactivity of nucleophilic addition reaction. So nucleophilic addition reaction, Na, depends on two possibilities. Number one, nucleophilic addition reaction is inversely proportional to plus I effect. Second, nucleophilic addition reaction nucleophilic addition reaction is inversely proportional to steric hindrance. So when there would be electron withdrawing group, right? So if there is an electron withdrawing group, right? So like minus I effect, then nucleophilic addition reaction would be more. And if it is plus I effect, then electrophilic this would be less. So firstly, like let's not go for A option because there are two phenols present. So already lot of sterically hindered, right? So this would go for the second rule. So let's leave for 1 minute this A option and let's compare B, C, D. These three are benzene. So can you see this NO2 is electron withdrawing group, right? So this would withdraw the electrons. So if that would withdraw the electrons, so nucleophilic addition reaction would be more in the D case. Okay, they are asked us in the increasing order. Okay, never mind. So D would be more. I will be changing that. D would be more, and then which would be more? This is the releasing group, and this is normal benzaldehyde. So C would be more, and then B because this is releasing group. You see, plus I effect decreases nucleophilic addition reaction. So plus I effect is more to CS3. It's a methane group, right? Electron releasing group. Alkyl group has a high plus I effect. So if the plus I effect is high, then nucleophilic addition reaction is less. So then C and then B and then A last. Why? Because this is lot sterically hindered, right? Two phenol groups are there, two benzene groups are already there to that. So nucleophilic addition reaction is inversely proportional to steric hindrance. So DCBA option number A is the correct answer, matching with our question. So let's go to the next question, 159. So in the presence of peroxide, styrene reacts with HBr to give X. W when X reacted with the magnesium and dry ether formed by CO2, and the hydrolysis gave us what, like Y, treatment of Y with PCl5 and the next with this H2PDBSO4. This is generally Lindlar's catalyst, the preparation for aldehyde. Gave Z. What is Z basically, right? So lastly, they are giving us ketone group. Lastly, they are given as ketone group, palladium BSO4. So obviously D option would be eliminated because any sense that would not come as an answer. So option would come from A, B, C, right? So let's go line to line. In the presence of peroxide, styrene. Let's draw the structure of styrene. You have to draw one benzene. And then double bond here, right? CS2, double bond, CS2, right? So there is one particularly this known as structure of styrene. So when you try to react with HBr in the presence of peroxide, that follows anti-Marconican's rule, right? So hydrogen would be added, which has already less number of hydrogen atom, and this bromine would be added, which has already more number of hydrogen atoms. So the structure was would come as in this way. So one Br here, right? And then what they have asked us to give X. So you got X right now. And when this X reacts with magnesium and dry ether, so the next reaction goes for magnesium dry ether. by CO2. So what this particular reaction would give to us, this would give us firstly when you do the step reaction. Although when this compound comes directly, you have to substitute carboxylic acid, but I can break the steps and tell you uh, how we do this. Just a minute. Yeah. So how we do this? This would be substituted as like when you react with CO2. So this would go for OMGBr. So directly, like, let me not this is a full mechanism. So I'll be telling in the class. Full mechanism would be taught in the lecture itself. I'll be uploading lectures. Series are there in the YouTube. You can see there. So we are covering the whole syllabus of 11, 10, 12, physics and chemistry, mathematics, biology, every subject. So you can see there right now, I'm telling you the correct approach. So the carbon would be, one more carbon would be added into this, and this would come as in this way, right? So one carbon would be added to this. And now if that carbon is added to it, now what they have asked us, this is what you're getting right now. And what would we remove? Like, see, what would we remove? You would be getting CS3, Mg, like MgBr you would be getting as the byproduct. That's not that much important. Right now, it's important that you're getting carboxylic acid. Whenever this reagent comes, just mind my words, when there is a halogen to it, you would directly, you can write that carboxylic acid. You can increase one chain, right? You can increase one change and directly you can write carboxylic acid to it. So that's what you are getting as answer right now. So this is what, like, this is why, right? Yeah, this is why. So now what they have asked, treatment for why PCl5. Now again, this is important reaction from haloalkanes aromates, right? PCl5, SOCl2, PCl3, PCl5. All these reactions are very important, 4 5 reactions in haloalkanes and haloarenes. So for this, how you would be solving again? So this you would be getting as, wait, let me solve it again here. Let me make a space. Yeah, my bad. Like, I cannot draw this correctly. Yeah, that's correct. So what you're getting, COCl, right? That's what you're getting. When you replace this PCl5, when you react with this, so you would be getting this now. COCl, this COH, OH would be replaced with Cl, right? And now this is again acyl oil group. So after reacting with palladium BaSO4, PdBaSO4, this is known as Lindlar's catalyst. This is a good question, I must say. Re-repeat this question, okay? So learn and re-repeat. Yes. So yes, what I was saying, this is BaSO4 Lindlar's catalyst. So that would give you directly aldehyde there. So what is answer coming as? Right? CHO would be there, directly CHO. So that's option is matching number A. That's the correct answer. Important question, right? So 4 5 reactions are given right now from your syllabus. If I look all the questions of chemistry which I have solved, this particular question was a good level. Every concept was mixed to this question. Yes, now to the last question, 160. They've asked for the pKb value, right? So now this pKb value is very important. Another question, what is pKb value? pKb value is generally, they've given us 4 options. This question comes from amine chapter. When there is a pKb value that decreases basic strength, when there is a high pKb value, that means a basic strength would be decreased. So correct order, correct way to this kind of question is to write increasing order of pkb, increasing order of basic strength and reverse the process. So which would have basic, high basic strength. Right now, before telling you this, let me tell you aniline and aromatic amines. Between aniline and aromatic amine, aromatic has higher basicity. Why? Aromatic amines. Why? Because basicity is something which is due to lone pair, right? So in the aniline you draw aniline, the lone pair are delocalized in the ring due to like resonance. And when there is no lone pair in the atom, right, the structure of aniline, when there is no lone pair itself in the nitrogen, you cannot say that particular compound is highly basic, right? Because some basic character is due to, and basic character is due to lone pair, right? Somebody who's having a lone pair is basic in nature. Everybody's know that. Like, so that if lone pair is delocalized in the ring, that means lone pair is going itself in the ring. That means like it would have a less basic character. So we say aniline has a less basic character than the aromatic amine. So aromatic amines resonance is not possible. So now let's look uh, between A and B. Aromatic amine would be A and B are the like aromatic amines. Aliphatic. Why have I written this aromatic? Just a minute. I was telling my bad. Like I was telling you. Add aliphatic. Aliphatic. Right. So like I told you, like in aniline, the lone pair is delocalized in the ring. So the lone pair goes in the delocalization of the ring and resonance are possible. I'll be telling you itself in the amine chapter in the detail. So right now aliphatic amine is a higher basic character, basic strength. So among now look, A and B are the aliphatics, right? So which would have higher? So the one who has a plus I effect more, right, is directly proportional to basic strength. So basic strength would be high of which compound among A and B? B would have high because this is tertiary, and then A would come. And now let's look in between C and D. Now, when you talk about this particular question, so which would have higher basic order? Obviously, C would have higher basic order because right now this lone pair cannot go in the conjugation, right? Now, right now, this lone pair cannot be delocalized in the ring. Why? Because aniline is right now not directly attached to the ring. So when it is not directly attached to the ring, obviously now you can comment on that. If it is not directly attached to the ring, so you can now easily tell, right? So which one, which has a higher basic order, you can easily tell. So if it is not attached to the ring, so C would have a higher one. Resonance is not possible. If resonance is not possible, that means a lone pair would still be there in the nitrogen atom and would have a higher basicity. So B, A, C, and then last one would be D. So let's revert this question. D, C, A, and B. Let's see the option. D, C, A, and B. D, C, A, and B. Wait. Oh, just my bad. Like we just spelled this wrong. We actually started wrong, but written wrong. Actually started right, but have written wrong. B greater than A, then would be D, then would be C, right? Because right now, in this, like if you talk about this particular case, this would have a lesser basicity. This would have a higher basicity. Why? Because right now, lone pair would not go in the ring. Here, lone pair can go in the ring, but here it cannot go in the ring. Because one CS3 is there, one this is there. So, the one like this is secondary, right? So, if it is secondary, lone pair would not go because it is not directly attached to the ring. So, B, A, and then D, and then C, right? So let's reverse the order for the PKB value. So PKB is something which has a less basic strength. So correct order would be what? Um, why are we getting this wrong? B, A, D, C. D, C, B, A. This option would be correct. A would be having the lower basicity. Actually, this options are incorrect. This full options are incorrect. The correct option, let me tell you. These four options are incorrect. Right now, it's not matching because it's like not there among this option. So the correct option would be D would be the higher, and then C, and then A, and then B. Right, for the PKB value. So any doubt related to this particular question, anything, I'll even have a look this particular question because like right now these options aren't matching, or like are we doing some mistake? I cannot identify actually, but as per my knowledge, we are not doing any mistake. But still, I have a look in this particular question because options are not matching with the correct options given in the question. So for now, that's okay, and we have done all 160 question of the chemistry portion. So in next chapter, next video, we'll be solving a few more questions. So I hope this series is helping you a lot. If you have any doubt related to any PYQ, even I'll be starting the lectures. So if you have any doubt related to anything, you can comment in the pin box, right? And you can even join our Telegram channel. So keep learning, keep sharing, okay, and keep scoring. Thank you so much.